Alrighty, so I'm going to post 3 videos of the 3 graphs that we did in class today so that you can watch them separately. The 3 graphs were the ones that were on this notes and practice worksheet. On Tuesday, on block day, we did number 1 and we did number 3. So today we did number 2 and the 3 on the back. So actually there's going to be 4 videos. So you can watch these one at a time if you were absent. I would suggest, if you were absent, go onto my blog, print out one of these blank sheets. Try these problems before you watch the video, or do as much as you can, and each one of them I want you to answer these questions that I have for number 1. Even though they're not repeated, I want you to answer those. So take a minute if you haven't done that, do that, and then come back to this video. Alrighty, so quickly looking at this graph and the transformations that take place, the first thing is we recognize the parent function is just going to be y equals the sine of x. So anytime we know the function, I'm going to have you guys immediately graph the parent function. So we know at 0 degrees, sine is our y coordinate, it's at 0. And if we think about our unit circle, it's just the best way to think about it, our y coordinates are going to be 0 here, every multiple of 2 pi. So there would be my x-intercepts for my parent function. It reaches 1 at pi over 2. So at pi over 2, it's going to reach a peak, and at negative pi over 2, it would reach a minimum, it would be negative 1. At 3 pi over 2, it's going to be at negative 1, and at negative 3 pi over 2, it would be at positive 1. So if we sketch what that graph is going to look like, there we have it. And we talked about in class today not needing to label the points on your parent function, but really needing to label the points on your final graph. So this just gives us a baseline to work through all the transformations that might take place. So the next question, is this graph reflected? The answer is yes, because we see this negative value in front. A is negative. So yes, it'll be reflected across the x-axis. So the next thing that we'd want to do is take our parent function and reflect this guy. So all the max values will become minimum values. Obviously points that are x-intercepts, they can't be reflected over the x-axis because this is the line of reflection. And all our minimum values will become maximum values. So they're just flipped over. So in this case, if I were to sketch that, I'll sketch it here in a different color. This is going to be the result of my reflection over my x-axis. If you prefer to erase the first graph, you can do that. So just remember that now we're using the blue graph. The next question, is there an amplitude change? No, it's still going to be 1, even though it's flipped. So the amplitude is still, no, A is still equal to 1. Is there going to be a horizontal shift? The answer is yes, because we have this value added or subtracted within the parentheses. This is like an h value, so it's going to be shifted right pi over 4. So what's going to happen is each one of my max values will get shifted right pi over 4. All of my min values will get shifted right pi over 4. And all of my x-intercepts will get shifted right pi over 4. So we talked about in class, right now we've got to mark where those intervals are going to be. So I'm going to add in my fourths. So here's 1/4, 2/4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So if I label those 1/4, 2/4, 3 pi over 4. So we see my odd ones are the only ones I need to label because my even ones will get reduced. Sorry, of course, these are all negative. So each one of these graphs takes a little while. 8 pi over 4 and 1 more fourth would be 9 pi over 4. Shift that is clearly labeled, that it crosses at these points. So I see here it clearly goes through 5 pi over 4 and I have that labeled. But it's not so clear what my maximum values are here, so I'm going to label these. So here it used to be at negative pi over 2, got moved to 4th. So this point is negative pi over 4, 1. This point used to be at pi over 2, it got moved right oh sorry, yeah, it got moved, it used to be at 3 pi over 2, I'm sorry, and it got moved right pi over 4, so this is actually going to be 7 pi over 4, positive 1. This minimum value used to occur at pi over 2, got moved right 1, so this is 3 pi over 4, negative 1. And this guy used to be at negative 3 pi over 2, got moved right 1, so it's at negative 5 pi over 4, negative 1. And I knew I could call that my final graph because the last question was, is there a vertical shift? The answer is no. There's no value being added or subtracted out here, so there's no vertical shift. So I'm done with my function.